Greetings, dear Group A. My name is Nilesh.
I'm Hawya.
I'm Tamika. I'm Susan.
We will be showing you guys about autonomously controlled sorting robot for warehouses following the title of navigating efficiently through strategic tracking. So this is the map that we've made to simulate what a warehouse would be. We used ROS and a LiDAR sensor to map out the entire environment of what a warehouse is. So, to simulate the medicine bottles, we actually made shelves, 3x3 shelves, each shelf containing one 3 medicine bottles. So, on each medicine bottle, we'll have one RFID card. This RFID card will contain the details about each medicine bottle, containing the string quantity, which will be chosen once the user selects the medicine bottle. This card will be scanned by the RFID reader. The RFID reader will be placed onto the robot arm. So once the user selects the medicine bottle, it will be picked up from the shelf. First, the scanning will be done. You will scan the RFID card. There will be a confirmation. Once it's confirmed, then only will the robot arm actually close its hands and pick up the medicine bottle. The robot card has 3 shelves. We separated the card into 3 shelves so that we can provide more space for when making it and for having the components. The first shelf contains the robot tires and the motors as well as the battery for the car. Then we also have the ultrasonic sensor here. The car has 2 main power supplies. The first power supplies the motors, and then the other supplies the 3 microprocessors that we have. We have one Raspberry Pi, one Arduino Uno, and one Maker Uno. The car also has a robot arm. As I said earlier, this robot arm will actually pick up all the medicine bottles. For the users to use our product, we made an application. This application has 3 main buttons as shown. The first button will allow the user to enter a new input for stock. The first input will be the name of the medicine. Second input will be the quantity. The third input will be the expiry date. Then there's a second button. This second button will have a drop-down menu which will contain all the current stock available, which the user can select the stock and then press submit, and then the robot will go and pick up that specific medicine. All this information is stored into a cloud. This cloud is made using Firebase. This Firebase cloud shown here contains all the string values and all the expiry dates and all the information. These string values is in such obscure way because this is how the Raspberry Pi actually reads the string.
So I have some questions for you regarding to the robot itself because I have a warehouse now. So what is the thing that you are going to supply to the warehouse?
So when you actually purchase a product, we only serve you with the robot because this robot comes with a LiDAR sensor and its own software capable of mapping ROS. So you'll be able to map your entire warehouse and save the location of the shelves for pickup later on of the packages. This product also comes with a free application that you can download off Play Store. This application is what I showed earlier, will allow the users to select and enter new entries.
So I have seen this really complicated, this robot. So is it easy to actually operate the thing in the warehouse?
Yes, actually the setup is very easy. As I said earlier, the setup, all you need to do is just download the application from the Play Store. Then you just need to enter down the available stock you have. Then you can already use the drop-down menu where you can select the medicine. And setting up the robot, all you do is actually just set up the initial position, and once the mapping is done, the robot will be able to move to each shelf and pick up the medicine bottles.
I see. So what is the scalability of this robot actually? Like how big a warehouse can it be? Really big warehouse?
Yes, so actually robot can be used for big warehouses. So this robot is capable of going down a single row, for example. So for if you have different rows, you can have another robot there dedicated for each row to avoid collisions with each other and conflict of interest.
So in this warehouse environment, did you actually take account into the safety issues in the robot?
So we have thought about that. We've implemented an ultrasonic sensor. This ultrasonic sensor will be used for obstacle avoidance. So in an example scenario where the robot comes close to an obstacle, for example, is about to collide with a person, about to collide with a package or a wall, shelf, it will bring the robot to a complete stop. So this avoids any potential injuries, any potential damages to the robot.
I see. So can you explain again the overall tracking? How does it track the thing in the warehouse?
So for the user to actually track the products in the warehouse, since all of this information will be entered into the application, these are all saved into the cloud Firebase that was made. So from this cloud Firebase, the user will be able to download a file containing all of this information about the products through the third button implemented in the application, the download button. This download button will download the list of all the products and the user will be able to